Okay. How comfortable or how much of thermodynamics do you guys remember? Or at least an idea of what is that chapter all about? Like, what have you understood
Heat.
from that?
Heat.
Heat, yes. Most of it is heat. So thermo naam mein hi hai, heat related, dynamics is like changes. So thermodynamics deals with what are the energy changes that occur. So the physics part of it will deal with work versus heat, and you have first law of thermodynamics, second law of thermodynamics. How do you manage energy? How do you convert it into mechanical energy? How do you convert it into heat energy? Itna work karne se how much heat will be generated? Like that. So energy is neither created nor destroyed. It's just transformed into one form to another, right? So that is the basis of your electricity generation and electricity being converted into your fans and lights and all of that, right? So whole of thermodynamics deals with the numerical calculations around that. Okay, agar itna temperature, like if I heat it, it's at 35 degrees Celsius, let's say this water. If I give it so much heat, it converts into steam. And then abhi states of matter mein, you guys have read that if you increase the temperature, then the pressure increases. Because of that, like the motion of the molecules increases. So fir, with what force can they push the turbines? Like what is the energy transfer over there? Like itna temperature difference hai, kitna energy pa sakti hu main? How much of it can be converted to electrical energy? So thermodynamics deals with those sort of calculations. Abhi is chapter mein, we are going to look at energy changes specifically for chemical reactions. Okay. So heat ke basis pe, what types of chemical reactions do you guys know of?
So like when heat is used?
Combustion.
Combustion, yes. So that's one specific type of reaction. But generally, you can classify them into two categories.
Exothermic and endothermic.
Exothermic, endothermic, right? Exothermic mein, what type of reaction is that? What happens to heat in that?
Heat is
Heat is
given.
released.
Heat is released.
Atomic heat is absorbed.
Yes, right. Now you can use this heat for a lot of things. So have any of you gone to any snowy place or extremely cold place? No.
Yes.
You see, okay, Rishad has gone. Okay, have you guys heard of Arnav Adit also? Okay, have you guys heard of something called heat warmers? Heat warmers,
Yeah.
hand warmers.
Yeah.
Have you used it?
No, I never used it, but I've heard of it.
Is it similar to like seat warmer or something like that?
Seat warmer comes equipped with the car. That works on a different principle. So I want to focus on hand warmer. So like Aditya's idea.
Might have used it, but I don't know.
Can you explain what they are or where you've seen them? If it is like somewhere online or something like that.
My grandparents owned it. Like right now, they are not in India, so they use it in US right now.
Have you ever seen them using it or no?
Yeah, I've seen it. I've seen them wearing it. But actually, I don't know the principle of it, unfortunately. So I don't want to give any false info.
No, like just tell me what you observed, not the principle behind it.
Like they had this like a thing around on their arm, ekdam aise. So like they were like much comfortable to be in the cold weather rather. So they were.
I'll just share.
It's like a bag containing something which like warms things up.
That's better. Yes, it's like a bag containing something, and as Adit said, like using that, it makes the cold bearable. Matlab, they give some sort of warmth. So you can see here images of hand warmers. you have a small container and then you just hold it and you get heat from it. So this container may what you keep is something like this. You have packets of this. So random packets of heat, how is it generated? So that is
But
because
isn't it better just to use gloves?
so only gloves will not work. Again, it depends on the thickness of the gloves. What if it is too cold for gloves? So a lot of people like wear gloves or mittens, and then for extra heat, they also hold this. Okay, so this thing inside you have some chemical substances, and then how you use it is whenever you want that warmth, you kind of disturb it, like you either shake it or you just press on it, basically give some sort of a disturbance. तो इसके अंदर जो भी है, those chemicals react, and that's an exothermic reaction, and then heat is released and you use that heat for your warmth. Now, how do you produce this sort of a substance? And then you also need to ensure that it doesn't get too hot that it catches fire, because then it doesn't make sense. It should produce enough heat that it's useful to you. Heat produce ho raha hai, but if you can't feel it, there's no point holding it. So the sort of calculations that go in identifying what chemicals to use key so that I get this much amount of energy. Also, ऐसा नहीं होना चाहिए कि all of the energy is released at once. Like it should not be an explosion. It should be a slow release so that you can hold it, use it for like an hour, 2 hours, वैसे. So the sort of calculate.
Does it like run out of heat?
Eventually, yeah. Then you need to. I'm not sure, but you may have like a rechargeable thing, like you put it in the fridge or you put it in like vacuum seal. Like basically, you make the condition so that the equation, like the reaction, is reversed, or it's like a use and throw thing. You get it both ways.
Ma'am, so I have a thing in the house which basically is a bag, and inside that there is like a gel or something like that which you can use if you have pain, and then if you just charge it, it will become hot, and then you can just keep it on your pain. So is it like similar to that?
Depends. Like what you're saying, that gel may retain that heat. Like then it is related to the specific heat capacity and the other things. But yes, all of these calculations that go in figuring these things out, kitna substance dena chahiye, how much electricity, how much temperature it needs to be heated, all of that is like involves your thermodynamics. That's what it's a study of. So now this chapter is your introductory thermodynamics. You'll be introduced to a lot of new terms that you use in this whole concept. So abhi you're learning it as a chapter, but once you get into degree level, if you're doing engineering or something like that, thermodynamics is its own subject. So it's a huge branch of physics/chemistry. What I was saying, in the context of chemistry, you're going to learn about the different energies that are involved in reactions. Reactions are basically bonds breaking, bonds forming, right? And those bonds essentially contain energy. Like, isliye, when bonds break, a lot of energy is released. Bonds are formed. It basically like traps energy. So if you're burning carbon, there's a lot of like carbon plus oxygen gives CO2. Also, a lot of heat and light are released because the whole energy contained in the bonds between individual carbon atoms versus individual oxygen atoms is a lot more than the energy you have in carbon dioxide's individual bonds. So it's like you have different enthalpies. There's something called Gibbs free energy. So reactions are related, whatever types of energy are there, you'll be introduced to all of that in this chapter. Okay, so take it as that, a lot of new terms. First, this whole chapter is basically learning all of these different terms. So yeah. So thermodynamics. So first, we have to define, like I said, it's a study of energy changes for a particular reaction or something like that, right? So what exactly are we studying? We have to define those whatever. So you have something called a system and something called the surroundings. So system and surroundings are exactly what you might think of when you hear these names. Together, they make up the universe. Okay, so system is basically what is being observed. So if you're looking at the reaction of the hand warmer, then that packet of the hand warmer, uske inside jo chemicals hai, that is the system. If you're looking at the heat changes of water turning into steam, like suppose you're heating it in a test tube or a beaker, then that container is the system. So system is what you're observing and studying. Surrounding is everything else around it.
The water won't be the system.
Water is the system. Surroundings is everything around the water. In fact, the whole universe comes at a surrounding, counts as surroundings. But because you don't really care what's happening at Pluto when you're heating water in your kitchen, right? So for practical purposes, you consider surroundings as the space surrounding your system. Okay, so for hand warmer, it's like everything outside the packet. So it'll be your hand and the air around it. So all of that is surrounding. So system plus surrounding is everything in the universe, like where everything is contained. Okay. And the thing that divides the system and surrounding is called a boundary. These are English words only. You have used them, you know them, you understand them. Okay. So boundary is what divides the system and the surrounding. Around.
So so the water and the glass both is the surrounding, I mean system, and then around that is the surrounding.
Yeah. So the water is the system. The beaker itself is the boundary, and everything outside the beaker is the surroundings. So hand warmer ke case mein, the chemicals inside is the system because that's where the action is taking place. The packet is the boundary, and everything outside the packet, your hands, air, gloves, clothes, whatever it is. So that would be your surroundings. So boundary, you have two different types of boundary. Okay, so boundary is divided into nine. Like you have something called a diathermic boundary and an adiabatic boundary. Okay. So diathermic boundary is something that allows heat to pass through. And adiabatic boundary does not allow heat also to pass through. It's completely insulated. Okay. So you can think of it as if I'm taking a random plastic bottle. So depending on the environment ka temperature, if I put cold water in it, heat is going to enter the bottle, and then the water inside is going to get warmer. So it allows heat, like plastic bottles allow heat. So that's a diathermic boundary. But if I take a thermos flask, if I put some hot coffee in it, thermos flask does not allow any heat to pass through it. Like hot substances remain hot. So that would be an adiabatic boundary. So this matters because eventually when we do the calculations and all, yeah, that's what it is, right? Like if heat is lost, you need to calculate, okay, how much heat is lost. So if it remaining is converted into work, वो सब होगा. So if question में दिया है कि it's an adiabatic system, adiabatic boundary, then you will do your calculations based on that. Yeah, Arnav, Kaveri, Sanat, once you're done, and Rishit. So we'll discuss the next part once you're done.
So like in the example of a hand warmer, it has a diathermic boundary, right?
Correct, because you want that heat to escape. Yeah.
So it will be exothermic also, right?
Exothermic is the type of process. So you use the word exothermic to describe कि क्या process है. अच्छा heat release हो रहा है इसलिए exothermic है. Diathermic, adiabatic, these are the things you will use to describe boundary. So the boundary itself is not releasing heat, no, it just has the property कि अगर heat है तो we're like, okay, you can pass through. We are not blocking you.
Right.
Huh?
Could you explain the plastic bottle example again?
Just to give you the contrast between diathermic and adiabatic. So if I take a plastic bottle, if I put some hot or cold water in it, what will you observe? Like, can you feel the heat, hot water ka heat from outside the bottle?
Yeah.
So you're feeling the heat, matlab that heat energy is traveling from inside the bottle to all the way to outside your hand, right? It's allowing the heat to pass through. So plastic bottle would be an example of diathermic boundary. तो वही मैंने फ्लास्क में डाला है hot water. So if I touch the outside of the flask, can you feel the heat of the water?
No.
You're not able to feel it because there is no heat energy traveling from inside to outside the flask. So, that flask is like blocking all the heat. It's not allowing heat to pass through it. So that's an adiabatic boundary.
Ma'am.
Yeah.
So, if the heat is not basically if it is not allowed to go out, then the thermos flux should technically retain the heat forever, right?
Ideal case may yes, but you've seen in the case of gases, like nothing on the earth is 100% ideal. That's the closest we can get. Okay. All right. So system is like the things inside this, right? So depending on, just like boundary, depending on the properties of a system, you have different types of systems. So first type of system is you have open system. Then you have something called a closed system. And you have something called isolated system. So open system, closed system are pretty easy to understand. Think of a bottle that is open versus a bottle that is closed. दोनों में difference क्या है?
Air
One
is
allows
trapped.
heat to escape.
Heat. So like अगर bottle closed है तो heat भी escape नहीं होगा क्या?
Depends
Come
on
over.
like what material it's made of.
Right. But everything else remaining the same. What is the only difference between an open bottle and a closed bottle?
The environment can interact or something like that.
Yes, interaction between environment.
Open bottle doesn't have a boundary, and like closed bottle has an extra boundary.
It's still a bottle, like ये boundary तो होगा ही. So take that further. In fact, Kaveri also said something. Air is
The
trapped.
open bottle is direct in contact with air.
Okay. यहाँ पे भी if it is half filled, it is directly in contact with the air that is inside, no?
Could we say that like an open bottle, like there is energy exchange between system and surrounding?
Closed bottle में भी energy exchange है ना? If I put hot water, heat will trap, escape out.
Yeah, but it's not direct. It's like through the boundary.
Doesn't matter. Like in thermodynamic sense, the kind of the same thing.
Closed system like that do not have like an exchange of matter around it or something.
Yes,
Like while the energy you can still like exchange with it, like heat can still be felt.
correct. Adit got it. So whoever said air is trapped and Smera also said something, take it further. So open bottle may I can add more matter into it. So matter exchange can take place. But if I close it, whatever matter is inside, like the water, air, itna hi hoga. Like that is constant. I cannot take anything out. I cannot put anything extra in. So that is the difference between an open system and closed system. So open system may delta M is not equal to 0. Like there is change in the mass of the substances, like matter can be exchanged. And delta E is also not equal to 0. Heat also can be exchanged. So you can write open system can exchange matter and energy. Or wait, I'll just put it in a different way. So open system can exchange matter and energy. So basically matter ke liye delta M is not equal to 0 and delta E is also not equal to 0. Rishit, yes, E is energy, but use capital E for that. Brackets. And in the case of a closed system, exchange energy, but not matter. So exchange energy, so delta E will not be equal to 0, but cannot exchange matter, so delta M will always be equal to 0. Change in matter, matter is not changed. Add nahi kar sakte, subtract nahi kar sakte, so delta will be equal to 0. And isolated system, so on the basis of this, can you figure out what isolated system would be?
No change in heat, no change in matter.
Yes. No exchange.
So for the closed system, are we also considering, like, are we considering the plastic bottle like with the cap on?
Yes. So I can't, so I can heat up the water by putting it in a microwave or something, but I can't add more water in it. So delta E is equal to 0, delta M is also equal to 0. Yeah. So yeah, like you can see how this becomes relevant for your calculations directly. So depending on what type of system it is, you can use these for, in your calculations, equations form karne ke liye.
Ma'am, what is an example of an isolated system?
A closed thermos flask from your real life. But industry may, I can't think of anything specific, but you can create like a reaction vessel in such a way that heat is not let out, it's all like trapped in. You can have it like vacuum lined with reflective surfaces, so by conduction, convection, radiation, like heat is not given out. From your everyday life, like if you had to imagine it, closed thermos flask, can't add anything when it's closed, and thermos flask hai to energy exchange bhi nahi hoga. So Arnav, Kaveri, Sanat, Rishit.
What about like nuclear reactor?
Nuclear reactor, that's interesting. So the reactor itself see, nuclear reactor में क्या होता है ना? So you have the reactor vessel, but you need to use the energy that is the result of whatever nuclear fission reaction taking place, right? So how that energy is used to generate electricity and all that is, you have a pipe with water running through it. So whatever energy is released as a result of your nuclear reaction, that is used to heat up the water, convert it into steam. So then that steam basically rotates your turbines that is present, and then this motion is converted into your electrical energy generator, AC generator, DC generator, all of that. So, oh yeah, purely the reactor, it would be isolated because this is not getting into it. So I can consider the water pipe ka system as a different system that's carrying the heat energy, because the water will be inside the pipes. It's not gonna go into the reactor. Yeah, nuclear reactors would be isolated. Yeah, that would be the logic that I apply, but I need to go study the
The water would be like a closed system though, right?
Water would be open because you're letting the steam, this thing, and then that goes through a condenser. And
No, like when it's like near the nuclear reactor.
if
in
I
that.
find the boundaries to be just like here and here, yes, it's closed because matter exchange bhi nahi ho raha hai. Energy exchange. Wait, so nuclear would be closed system because reactor, like there is exchange between the reactor and the water that is going and coming in. So ideally you need to define what is your system. Like, are you observing the water? Are you observing like this reactor, like the whole thing together? Like you need to define the system, then you can figure out whether it's open, closed, or isolated.
But would it still be an exchange? Because like the nuclear reactor is like heating up the water, but it's not actually like an exchange of energy, right?
It is exchanging. So that's what you need to define it. So if I consider water to be an external thing, if that's not part of my system, then the reactor is exchanging energy with the surrounding. Yeah. Okay. Now comes properties. Let's talk about properties. So this is like system, surroundings, general, overall kya ho raha hai. Now let's get into the system. System ke andar you might have chemicals, gases, water, whatever, some matter will be there. You use some properties. You have physical properties, chemical properties, all of that, right? So properties are things that are used to describe any substance. Like color is a property. Solubility is a property because it's telling you whether it's going to mix in water or not. Reactivity is a property. Electronegativity is a property because it's telling you, okay, what sort of charge it's going to get, what sort of reaction it's going to undergo. So now thermodynamics ke case mein, we don't deal with atom level ke properties. We deal with properties that are on a macro scale. Like we don't really care about what is the polarity of the bond, what is the charge of the ion. Like that's not gonna help us study thermodynamics. We care about, if I have a box of a substance, a gas, let's say, iske andar pressure kya hai? What is the temperature of this? What is the volume of this? Like these are the kind of properties that I care about. And you cannot define these properties by just looking at one atom of that thing. Like if I know that there is O2, and if I know ki oxygen ka atomic number is 8, mass number is 16, that's not going to help me figure out what is the temperature, pressure, volume. I need to know how much of the oxygen is inside the box to be able to figure this out. Right? So there you have like certain terminology to identify, okay, I care about these type of properties, but not these type of properties. So one, they're called macroscopic properties.
Ma'am, but if we are, if we have to like find them, at least two of them will be given, right? Either volume pressure or pressure temperature or volume temperature or something like that.
Oh yeah, like cases may, yeah, like definitely. If you have specific situations where you need to figure out the pressure, you need to figure out the volume, you'll be given other variables related ki wahan pe temperature kya hai, all of that stuff. Okay. So macroscopic properties are the properties that describe the bulk. Describe the bulk behavior. Okay. If I hypothetically isolate one molecule of O2, it's not going to tell me if I take like cylinder of oxygen, to kitna pressure will be exerted by it. So pressure is a kind of property that only comes from having a whole lot of O2 molecules. Like pressure is something that describes the cylinder full of oxygen molecules. It could be a big cylinder, it could be like a small cylinder, but pressure is something that describes what the group as a whole is doing, not what individual atom is doing. So pressure is a macroscopic property. Similarly, color is another, like if I take a single atom, uska color doesn't make sense because atom has some electron clouds. Electrons are always shifting, excitation, de-excitation, wo sab ho raha hai. So I don't know, like looking at a single atom, what will be the color of the atom. But if I have a whole bunch of colors, atoms together, if I have like paint ka bottle, or if I have like this, all of the atoms, molecules arranged in this way, I can describe ki, okay, the solid ka color is black. It's absorbing all of the colors, all the wavelengths of light, right? So temperature, volume, pressure, color, density, like the things that describe the bulk behavior of a substance, so they come under macroscopic properties. Okay, so macroscopic properties are of two types. So you have intensive properties and you have extensive properties. Okay. Any idea what intensive, extensive properties could be?
Interior properties and exterior.
Exterior क्या होता है? Interior, exterior क्या होता है? Like, are you saying
I mean, like
property?
if you see it from outside and when you see it from inside or something like that.
How do you define inside, outside? Like water, if I look from inside water, will it be different from if I look at it from outside water?
If it is in a container.
Whether it's container or swimming pool or ocean, difference kya hai?
Intensive is something that is within the object, like the body. Like for example, heat can be an intensive property because it's within the body.
Closer. So intensive property is something that's like intrinsic, you can say. That's like nature of that thing. Like extensive property, I'll describe extensive property and then usse intensive will start making sense. So extensive property is something that will depend on the extent of the substance. Extent matlab how much of the substance is there. So basically this depends on the quantity. And intensive property is the opposite of it. So this does not depend on the quantity.
So could it be like intensive properties is like a characteristic property of a substance,
Yes. Yeah, it's
and
like,
extensive property is like something which depends with the quantity. Like if there's this much
yes,
of water in a container, it will exert this much force on the walls of the container.
absolutely. Kinda, but it doesn't have to be all the time. Okay. For example, extensive property, an obvious thing I can think of is mass. So if I have a bigger substance, lot of mass, smaller substance, less mass. So mass definitely depends on, कितना substance है मेरे पास. Can you give me another example of an extensive property? Something you can think of?
Pressure.
Pressure. No, because think about it. So pressure would be an intensive property because what is the pressure of the air that's just trapped within this bottle?
As much as atmospheric pressure.
There you go. Now, what is the, okay, got it, Arnav. What is the quantity of air that is trapped inside the bottle versus that is there on Earth? Are they comparable?
No.
No, not really.
This is a small amount, Earth के ऊपर. So even though the quantity of substances is different, they both exert the same pressure. So it's not like dependent on the quantity of the substance, right? So pressure
Ma'am,
is intensive, but mass, like if I isolate itna sa air ka mass and if I compare it to the whole mass of air on Earth, there's gonna be a difference. It depends on the quantity of the substance. Yeah, Rishit.
ma'am, could magnetism be intensive property?
Magnetism. Hmm, I'll have to look into it because magnetism is something weird. Like magnetism, I don't think magnetism is a macroscopic property at all because it depends on the electrons present in the atoms. So I don't think we'll consider that. Okay, I'll give you another example. You guys tell me whether it's intensive or extensive. What about temperature?
Intensive.
Intensive.
Intense.
Yeah. So temperature, a gram of a substance can be like at 10 degrees Celsius. A kg of a substance can be 10 degrees Celsius. It's not like zyada liya to temperature increases. It may decrease. It's independent.
Ma'am, could you explain the first part, pressure being an intensive property?
So pressure does not depend on how much of the substance is there. Like I can take a 1 liter tank of oxygen cylinder, maintain it at a pressure P. I can take a 100-liter tank of another gas cylinder and I can still have maintain it at the same pressure P. Like sure, other properties differ, like the temperature may differ and all that, but pressure on its own doesn't depend on, oh, I need to have 10 kgs of a substance to have 10 atmosphere pressure. Right. That's it. Just like temperature, it's you quantity doesn't control temperature.
What did you say, like at the start, what did you give the example as the intensive property? Like with using the water bottle?
Water. Oh, so I was talking about pressure, like the pressure that's trapped or in of the air inside the bottle, which would be what, like 750 ml of air versus atmospheric pressure. Like both exert atmospheric pressure, which is the same amount of pressure, yet they both are like completely different quantities. So pressure doesn't really depend on the quantity. It's a different macroscopic property. What do you guys say about volume? Intensive.
I think volume will be extensive.
Volume is extensive. Yes.
Doesn't that depend?
Mm,
Like if you had cotton or like a solid, it depends on quantity, but on gases, like it doesn't.
yeah. So volume of liquids and solids absolutely depends on quantity, but for gases, because of weird nature of gases, it doesn't really depend on the quantity. So apart from that, I'll just give you some examples. So density is an intensive property. Then concentration is an intensive property, and surface tension is an intensive property. So extensive properties, take examples, you have mass, volume, enthalpy, entropy, work, number of moles, and specific name like heat capacities like Cp, Cv. So these are all examples of extensive properties. Some new things, a lot of it you're familiar with, density, concentration, all of that you're familiar with. Extensive may you came across some new things like heat.
What was this?
Yeah, these are the things.
H is heat, right?
Enthalpy.
Oh.
Yeah, these are all like new terms. This is what we are going to be dealing with in this whole chapter. So
How is like heat an extensive property? I didn't get it.
So heat, this is called enthalpy. H is enthalpy. So heat energy, Q is a different thing. H is enthalpy, that takes into account the work and other things. So when we discuss more about what is enthalpy and how it figures, like it'll be clear.
Ma'am, what did you write about after writing rho? What did you write? Concentration.
Yeah.
And after that, standard temperature.
No. This is surface tension.
Oh.
What does N and CV stand for?
N is the number of moles. Wherever you come across N, it's basically the number of moles. So PV equal to nRT, N equal to given mass upon this thing. N is basically number of moles. CP,
What is this?
What?
What is S?
Oh, this is surface tension. It's not in
No. In the extensive properties after heat enthalpy.
S is entropy.
What's that?
So that is a measure of chaos, disorderliness. We'll discuss that in the chapter. So the first part of the chapter deals with understanding work versus heat energy versus internal energy. And then the next middle of the chapter will be dealing with enthalpy. So you have different enthalpies: bond dissociation enthalpy, electron gain enthalpy, ionization enthalpy, atomization enthalpy, solvation, hydration enthalpies, like all of that. And the third part of the chapter will be dealing with entropy, how it affects chemical reactions and all of that.
Oh, ma'am, if enthalpy is an extensive property, then how is temperature also not an extensive and why is it intensive?
There's a difference. Like enthalpy is, so temperature is an indicator of the internal energy, the motion of whatever atoms, molecules are there. That's temperature, right? So that we call something called internal energy, how much energy is already present inside. So that's an intensive property. Enthalpy is internal energy plus PV, like the work done by this thing. So we'll expand more on enthalpy. Like there's a whole section that where we talk about enthalpy. It becomes clearer there.
Okay.
Sanat's asking, is gravitational force extensive property? I would imagine so. Yeah, it's dependent on the mass, no? Like 3 kgs of something will exert less gravitational force than 3000 kgs of something. So, yeah. But again, like gravitational force is not an inherent property of a substance. It is like forces between one substance and the other one, right? So it's not a macroscopic property. Force is a completely different concept. But gravitational acceleration, that gm by r square, would be an extensive property because different planets have their own accelerations, right? Okay, Adit is done. Arnav, Kaveri, Smera, Sanat, Rishit. Another fun fact about like intensive extensive property is usually the ratio. Okay, I don't have space here, can write it down. So ratio of two intensive properties, sorry, no, ratio of two extensive properties ends up being an intensive property. Case in point, density, like density equal to mass by volume. So mass per unit volume. So both of these are extensive. Ratio of them is this thing. Concentration, number of moles per unit volume or mass. Ratio of two extensive gives you an intensive. Now, because you're taking ratio, you're basically standardizing it to, okay, unit mass, unit volume mein kitna hai this particular thing. So that makes it become an intensive property because you're standardizing the quantity. So if at all you're wondering, oh, is this like an intensive extensive? If it happens to be ratio of two extensive properties, then it's an intensive property. Do that. Okay. Okay. Then we have something called state functions and path functions.
And the macroscopic properties are separately.
Now this is completely separate. So macroscopic properties are, you have intensive and extensive properties. So these are like what you use to describe a particular substance. Now state function, path functions are, they also describe, but it's not like characteristic of particular substance or something. It basically describes uh, the state of a particular system, you can say. Okay.
Ma'am, I had a doubt. I did not get how volume is an extensive property.
So volume of solids, liquids are extensive because if I take more water, it's going to occupy more volume. If I take less water, it'll occupy less volume. With gases, it depends on other variables also. Let's not like consider that. But as far as solids and liquids are concerned, definitely is an extensive property because it's dependent on how much of that thing you've taken.
Okay.
Yeah. Now coming to state function. So state functions, basically they describe the state of a particular system, and it is so that particular state doesn't depend on how you've arrived at that state. Okay, so for example, if I measure the temperature of a beaker of water or something like that, temperature is going to be T. Like whether I heated it up, like let's say temperature T equal to 40 degrees, like thermometer lagaya and it was 40 degrees. Now, if I heated it up from 25 degrees to 40 degrees, still ends up at 40 degrees only. If I cooled it down from 60 degrees to 40 degrees, it's still like at the end of the cooling down process, when I stick my temperature in it, I'm going to get a value of 40 only. Right? So 40 is like, okay, at this moment of time, is the temperature here 40 degrees. That is the state of that particular thing. So state functions, they describe the state without, and they don't depend on how you arrived at that particular condition. So it
Ma'am, when you say state, do you mean like the chemical state, like whether it's liquid or solid?
state matlab, so for that you use a word called phase. State is basically, okay, what pressure is it at, what temperature is it at. Yeah, the bulk property, the macroscopic.
Properties, right?
Yeah,
These are bulk properties, right? Basically.
yeah, bulk properties. So it describes a definite state and it's independent of the path taken. That's the main thing.
Ma'am, is it possible for you to explain what was state function again?
So that's what, like it describes a particular bulk property of a substance such that, like, see, to describe something, you can talk about the pressure exerted, what temperature it's at, how many molecules there are, what sort of heat energy is it giving out, like what's its enthalpy, what sort of work it's doing. You can describe it using all of these different variables, all of these functions basically, right? Some of them will depend on what path you've taken there. Some of them are just like, okay, at time 3:38, iska temperature is 40 degrees. When I measure it at 4 o'clock, it has cooled down to 35 degrees. Now, irrespective of whether I've put it in an ice bath or whether I've like let it cool naturally, whatever the thing is, it doesn't matter. Like मैंने अभी measure किया तो ये है temperature, फिर अभी measure किया तो ये है temperature. Whatever like that's just a definite state at that particular point of time.
So basically, for example, if there is ice, either you boil it or just keep it outside, it will melt. So that is what you're saying is the state function.
Yes. So you can think of it as distance versus displacement. I'll talk to you guys about path function also, and then you can compare both of them against each other. उससे थोड़ा clarity आ जाएगा. Now, in contrast, like state function ka opposite, or like the different thing that you have is path function. So path function depends on, okay, what is the path you've taken there. So this basically depends on the initial. So the initial state or the initial point, the path taken, and usse you'll get your final this thing. So it depends on all three factors. Like the path functions usually depends on what path you've taken, also like what direction you're going, how are you doing it, all of that. So like a very simplified example I can give you guys is distance versus displacement. Okay, so let's say I start off here, I end here. Now, whether I take this pink color ka path or the green color ka path, what will my displacement be? Will it be the same in both cases or different?
Same.
Displacement will be same.
So it doesn't really matter what sort of path I'm taking, right? It just okay, like during 5 seconds, my displacement is from here to here. That's it. But distance is going to matter कि कौन सा path लिया मैंने in getting from point A to point B. So the blue car distance is going to be different from the pink color car distance, which will be different from the green color car distance. Right? So the process or the path taken there matters in the case of distance. So similarly, state functions, path functions also. State functions, okay, like at this instant in time, ye hai mera state, 1 atmosphere at 35 degrees Celsius. And then when I measure it at a different time, it's going to be like a set, okay, itna pressure hai, itna temperature hai, itna volume hai, right? Path function, so examples of state function are things like pressure, temperature, volume, number of moles. Enthalpy is a state function. Temperature matlab basically your internal energy, U is a state function. Entropy is a state function. Bulk properties basically. Now path function ke examples are things like work done, heat energy. Like these are the ones that are relevant that you can consider. Why is this a path function? So basically work done can take a positive value or a negative value. So if work is done by the system, like suppose there is a gas hai andar, and work is done by the system, matlab, let's say it moved this piston, like yahan se it just moved it yahan tak. Okay, so this was the initial point, this is the final point. So the gas has pushed this from here to here. Matlab, it exerted a force that caused displacement. Work is done, matlab, it exerted energy to push this thing. So when work is done by the system, so that work done takes a negative value. So when you're doing work on the system, you're adding energy to it. So then that takes a positive value. So the value of work, whether it's positive or whether it's negative, and how you're doing it, like is it purely because of the motion, or are you adding or taking away some heat? So like the details of the process are matter, like start mattering to get the value of work done in a particular system, right? So that's why, because what path you have taken to achieve that final state, because that path matters, work done is a path function. But if I add heat, whether I take off heat, like uske liye, like the temperature, it doesn't matter how I've taken out the heat, whether I've cooled it down or whether I've done work on the system, whether I change the pressure or the volume, all of that doesn't matter. Initial temperature एक है, and then मैंने कुछ process किया, final temperature एक है. Like you can measure these specifically at different points of time, and you get very specific definite values. But for path functions, it depends on what you are doing. Like you won't get definite specific values. It depends on what exactly are you doing there. Okay. Similarly, heat also can take in either a positive value or a negative value. Suppose the surrounding is passing heat to the system. Like मैंने जाके furnace में रख दिया. Like if I put it on a stove, the surrounding is giving heat to the system. So then, the total heat, like change in heat in the system, I'll get a positive value because I'm adding heat from the surrounding to the system. Similarly, if I take away heat from the system, then I'm going to get like heat is going to be a negative value. Here, so what I'm doing matters. In this case, what I'm doing doesn't matter. Like, okay, at time t, if I measure pressure, temperature, volume, all of that is going to be a definite state. Path is like, okay, how am I getting there? So path functions describe how I'm getting there. You can think of it that way.
I just had one small doubt. It's not really related to this, but when you said about distance and displacement, you actually see that displacement, right? Like what path you have chosen, the shortest one will be the displacement. It's not like the distance what you will see, right?
Yeah.
In this path function.
Yeah, that's why I said that's a very, very loose analogy. It's not like an exact one-to-one. And you won't describe distance displacement as state or path functions. It's just to explain the contrast between both of them.
I have one quick doubt.
Mm-hmm.
Like you said in state function, like the initial state doesn't matter. So like, is it to say that it doesn't matter if you're like cooling something down or heating it, or is like it doesn't matter how you're cooling it down or heating it?
Both. State is at this specific point of time, what is my pressure, what is my temperature, what is my volume. Like all of these are definite things you can measure in a particular system. In a path function, acha 347 ho gaya, okay, what is the work done? Matlab, I won't be able to tell you. I kind of need to know ki kya kiya, like did the piston be pushed by this or was the surroundings that was pushing the piston down? Ki exactly kya hua wahan pe. So the path functions are affected by the path taken. That's why they're called path functions by the process. State functions are okay, us time pe state kya hai uska, that way. Okay. So now path taken is basically what we are saying is kya process hua. There are a lot of different types of processes also in thermodynamics.
Can
So
you go back?
yeah. Okay, so once you guys are done noting this down, we'll talk about the types of processes.
So if heat is given out,
Hmm?
will that be work by the system or on the system? I think it would be by the system, right?
No, heat and work are two different things. A system can give out heat and also do work. A system can give out heat while like work is being done on the system. Like both of them are two different like two different functions. They're not like dependent on each other. We can't say for sure unless it's like an adiabatic system or something like that, then only we can talk about acha work done matlab heat is given out or something like that. Under certain
So
conditions,
only
I can give
work
you
and
an
heat
answer.
energy are path functions.
Sorry, Sanat, can you repeat that?
Only heat energy and work are path functions.
There are others also, but abhi ke liye you can think of it as heat energy and this thing. Let me look at it.
Ma'am, could you go back to the previous slide just a second?
Iske pehle, this one.
Yep, done.
State functions are also called point functions. Like not in your textbook, but if you look at any other textbooks, other resources, or something like that, you can also see them described as point functions because they describe things at a certain specific point. So heat and work are like the most important, like something you'll come across at every level, right from the basics to others, to the most complicated, complex things. There are others like arc length and all, but they're very specific, niche kind of cases. So you won't come across them unless you get into a specific process or something. These two are the most important and most common heart functions.
Ma'am, could you go over path functions again?
What exactly about path functions do you want to know, Kaveri?
Q.
Q is okay, so W is work and Q is heat. So heat energy is represented by the variable Q. So when you're adding heat to a particular system, like let's say I took this vessel and I'm heating it up, like I'm giving heat energy directly. मतलब heat is transferred from system to surroundings, तभी heat का value positive होगा. Like when I'm describing the path function heat, it's going to take on a positive value. But if I'm transferring heat from system to surrounding, like let's say I already have boiling water and I just kept it on a table, surrounding is at a lower temperature, it's gonna happen naturally. Like whatever heat the system has is being lost out to the surroundings. So to fit, if I'm describing the heat of this particular system, it's going to take on a negative value because heat is transferred from system to surrounding. So I can't independently say, I can't, 4 o'clock mein dekhti hu kitna, like what is the heat? Like no, whether it's used to describe a process. Heat aa raha hai ki nahi aa raha hai. And because it's used to describe a process, it depends on the path taken by the, like how are you going from point A to point B depends on that.
Ma'am, just a second.
Ah, sure.
Done.
Okay. So now we look at different types of processes. Okay. So you have adiabatic processes. Adiabatic means the same thing wherever you come across it. So you have adiabatic boundary, right? So based on that, can you guess what adiabatic processes would mean?
Processes that do not involve heat or there's no change in it.
Processes with no heat exchange.
Yes,
Absolutely
heat does
correct. So अगर एक process है जिसमें dq is equal to 0, so no heat exchange. So that's called an adiabatic process. So question में if you come across it's an adiabatic container में I've done all of these. Adiabatic container मतलब there is no scope of heat exchange. So that process is going to be adiabatic. There's no heat exchange involved. All of these are very, very self-explanatory. Maybe one or two you might have to go through it, but then you have isothermal. Isothermal. तो ये क्या हो सकता है?
Controlled heat
There is
exchange.
no heat exchange.
So isotherms are a specific kind of graphs, right? So where have you come across isotherms before?
States of matter, there was a graph in which something was called isotherms. I forgot what exactly it was.
Look at the word. Iso hai, therm hai. See,
The kinetic energy part of
kinetic energy of particles, what do you use that, like, what is the one word or number used to describe it?
No idea, I guess. Nah.
You're gonna facepalm if I tell you what it is. So
velocity,
velocity kahan se aa gaya? So
kinetic energy, right?
yeah, but velocity would be of those individual particles, no? Here we're dealing it with bulk properties only. So dt is equal to 0. There is no change in temperature in an isothermal process. Kinetic energy of individual particles, like they taken together, they describe the temperature of a thing. So when you're increasing the temperature or decreasing the temperature, you're changing the kinetic energy of those particles.
Ma'am, but if you're not doing any heat exchange or anything, either way the temperature won't change, right?
So that you need to unlearn, like decouple heat with temperature. Heat is one way you can change the temperature. You can also change the temperature by doing work on it, by not getting heat involved in the process. Heat is nothing but the motion of those individual particles, like that's the internal energy. So you can do that by changing the pressure, changing the volume. Tabhi you don't have to like get fire anywhere close to it. So that's why path function, like heat is different, work done is different. Both of them are forms of energy. So we'll discuss work and heat in detail and the relation between them. Okay, next you have isobaric process. ये क्या हो सकता है?
No change in mass.
Bar, iso is like constant, same, that's what it stands for. Bar, like what would you associate the word bar with?
Isotopes, isobars.
Isobars.
Smera got it. Pressure. So no change in pressure. Let's use small p instead of capital. Okay. Then isochoric. So isochores are also like graphs that you might have come across in states of matter. So when you don't
Is dW 0?
volume, dV equal to 0. So isochores are PT graphs. So when you keep the volume constant, like isotherms are PV graphs where you keep the temperature constant. Isobars are VT graphs where you keep the pressure constant. So process may be isothermal process, temperature is constant. Isobaric, pressure is constant. Isochoric is volume is constant. Then you have a cyclic process.
What did you write after isobar? Baric?
Isobaric, dp is 0.
No, like after that.
This is isochoric. I'll write it clearly.
So no change in volume.
No change in volume. Yeah.
Could you like explain how, like choric, how does it relate to volume?
Greek, Latin, I don't know. I haven't gone through the etymology of it. But yeah, isochoric process is something where the volume does not change. Isochores are the graphs drawn at constant volume, so PT graphs. So yeah. I can give you like scenarios where you would come across it. So adiabatic is you can design the vessel in such a way that there's no heat exchange, like a thermos flask, for example. Uska hi principles use karke. Isothermal also, you can keep the temperature change constant, but you can allow heat exchange. Like if you heat, like let's say you take a vessel and you put some heat, and then if you want to maintain the temperature, you need to let this heat energy get converted into something else. So while keeping the temperature constant, the pressure and the volume may change. So all of this energy gets converted into work, and then this piston will get moved. So things like that can happen. Isobaric may you want to keep yeah, Kaveri, what's up?
I didn't understand the relation between the heat and the temperature. Like if the change in temperature is 0, I didn't understand how the heat is still able to pass through.
Heat is just a form of energy, right? So that heat energy is not being used in increasing the temperature of this thing. But if
Oh,
I'm adding heat, it needs to be converted to something else. Like if it's not
okay.
used on
Yeah.
particles of this, then it ends up, okay, these particles end up doing work on the piston maybe. So
Got it.
yeah, it's converted to in other ways. Uh, Isobaric, the pressure is kept constant. So again, it's a variation in the volume and the temperature. Like everything, let it happen at atmospheric pressure. All of your reactions, whatever happens, if as long as you're not using a closed vessel, if you're letting everything stay at atmospheric pressure, that becomes an isobaric process. Isochoric, uh, let's say you're letting everything happen in a like a sealed box. The volume of this box is not changing, so whatever you do inside it, heat may change, temperature may change, whatever happens, volume is not changing. So that's an isochoric process. Okay, that way. Cyclic process, what do you guys think cyclic processes could be? Cycle क्या होता है? Like when something is cyclic, you come across break the cycle, all of that. So think of it in like completely colloquial terms only. Like you have heard of the word cycle and all that. Definitely we're not talking about a bicycle, so that's for sure. So other than that, where else have you used cycle?
A process that repeats.
Motorcycle, for example.
So no, that's not what we're talking about, bicycle, motorcycle. But yeah, Ritu, something that repeats. Cyclic. Oh, मेरा video on नहीं है, sorry. So cycle is something that keeps repeating, right? So cyclic process is also exactly the same thing, a process that returns to the original state. Okay. So for example, so at A, it may have, let's say, P1, V1, T1. Then somehow, let's say you change the pressure. So then it goes to B, where it becomes P2, V1, T1. Then you do something else to it. So volume temperature change ho gaya, goes to a state C, where pressure is P2, volume is V2, temperature is T2. Then you do something else when, like then it goes to a state D, where pressure is brought to P1, volume is at V2, let's say temperature is at T1. Then you do something else, and then finally at E, you end up with P1, V1, and T1. So A and E are basically the same thing. Like जहाँ पे शुरू किया था वहीं पे वापस आ गए. So this is a cyclic process. So depending on what paths you're following here, overall energy may be released, energy may be absorbed, work may be done by the system, work may be done on the system. That depends on how you're getting from here to here, depends on the paths that you're taking. But if you look at the state initially and finally, you've gotten back to your original state. So that's a cyclic process.
Is it like I know that this isn't chem, but like Bernoulli's principle, where like the values adjust, like if one increases or decreases, but like the total is always the same.
Kind of. Yeah. That is actually true. So in this kind of this thing, like because if at all something increases, फिर P2 से वापस P1 आ रहा है, it's also decreasing, right? So if I compare like the total, like let's say this is what other variable can I take? This is, let's say, x1, x2, x3, x4. These 4 processes are taking place. If I look at the overall change in the internal energy or enthalpy, it's going to be 0. Yeah, so overall change in internal energy is also 0. Overall change in enthalpy is also 0. Because whatever you're increasing, you're again decreasing it by changing the variables based on that. So du is equal to 0 and dh is also equal to 0. In individual processes, something may increase, something may decrease, but because you're bringing it back to, like, v2 is back to v1, p2 is back to p1, so because of that, whatever increase in decreases, so overall change will end up being 0. So graphically,
So
yeah.
So is it like the water, how it turns into a solid, liquid, gas, like how we use freezing, evaporation? Is it also a cyclic process then? Because anyways you can switch to its own state.
Yeah. So if you're taking like the water cycle, that it's a cycle, it's a cyclic process. So temperature change हो रहा है, like उसका state change हो रहा है. So the pressure is changing, the volume it occupies is changing. So cyclic process. So like at proper application of this, like if you take up this chapter in physics, then you get more in detail, like you have Carnot cycles and things like that, the applications of it. Okay. Kaveri, was that from before, or do you have any more question?
Sorry, I forgot to do it.
Oh, that's okay. Cool. So Kaveri, Smera, Arnav, Sanat, Rishit. Once you're done.
Ma'am, I actually did not, like, I got this, but I had a doubt in state function. I didn't exactly get what exactly is the meaning. Is it that, let's say,
It describes the state of the system. System का pressure क्या है, उसका temperature क्या है. It just describes what state it's in: high pressure state, low pressure state, that way. High temperature, low temperature. Yeah, like that.
Ma'am, what is V in isochloric?
Volume. V is always volume. Like these variables never change. Q always used for heat. T is like capital T is always temperature. P is always pressure. V is always volume. Yeah. When do we get internal energy? Heat. Expansion. Heat capacity and all are not there, no? That's why we talk about internal energy, then first law. Okay. Okay, so can we go forward, Rishit?
Yeah, we can.
412. We'll finish off the types of processes. Then just before starting work, we'll have like a 5-minute break. So cyclic process ho gaya. Then you have reversible and irreversible processes. Definitions and what they mean. It's like whatever you guys already know about it. Reversible processes kya hote hain?
Ice to water.
That's an example of it, but
Oh,
how do you, what's special about a reversible process?
physical reactions.
Or a
You
state.
you can get the reactants back from the product.
In a specific chemical reactions, yes, but the idea is that, so a process that can be reversed.
I was going to say that, but I didn't know that the answer would be that easy. So
Things
trying to
are
come up with something better.
no, things are simple, like always keep it simple. See, in general in life, if you can express something in like really simple words, simple terms, so that you can explain it even to like a 5-6 year old, it means that you have gotten mastery in that subject. Like you can understand it very well, the inside out of it, that you can simplify it. Only
Too bad the examiners don't think this way.
no, you can absolutely use simple language. What examiners use is do is they look for whether um, you have gotten knowledge of the, like they just look for keywords that are scientific. Like for example, biology may you can't use child and baby, like use terms like embryo, fetus, because they actually mean something. But overall process and all, like descriptions, you can use simple terms. So reversible processes are something that can be reversed. So the reason why they can be reversed, like if you were to look into it, what happens at a micro level, like reversible process, what is special about them that you can go backwards with them is the change takes place uh, in at a very slow rate, that a tiny change in the state, like pressure thoda sa like zyada kiya ya kam kiya, that causes a change in the process. Yeah, so the change takes place, process matlab kuch to change ho raha hai, right? Like pressure is increasing, volume is increasing, decreasing, something is happening, some change is happening, that's a process. So if a process has to be reversible, like it is going inching at a very slow rate, that even a tiny change in the state or in any of the variables, like the direction of this can be changed. So contrast that with irreversible processes. So irreversible processes are the processes that cannot be reversed. So it's just going from, like point A to point B instead of inching along at a slow rate. यहाँ से ठक से इधर आ रहा है. So, you can't, like, so before you can apply any change, before you can apply any change to the conditions around it, the change has already taken place from here to here. Reversible process may, it is happening slowly, that changing the condition at any point can, you can change the direction of the process.
Ma'am,
Huh?
could you explain this changing the condition part again in your reverse?
Yeah. So I'm coming to that. So let's say process may, so we'll go back to the piston wala example. Piston hai, so we have a gas inside. Let's say, Ritu Singh, could examples of this be iodine versus fluorine reactions? Kinda. Again, Ritu, so that relates to the rate of reaction because of the properties of those things. Here, what is happening is, okay, suppose I have to change the temperature of this, like pehle T1 tha, I need to make it T2. Okay. And let's say T1 is less than T2. Like I want to increase the temperature of it. Let's say from 10 degrees to 30 degrees. Two ways I can do it. Either I can supply, so one way is to like supply heat to it. So adding Q to the system. Another way I can do it is by changing the temperature, by doing work on the system. So if I push this piston, it increases the pressure inside because the volume is being decreased. So pressure increase matlab temperature bhi increase hoga. Like ideal gas loss, something that you guys learned. Right? So two ways to do it. Now if I supply heat to the system, I am directly targeting the internal energy of the molecules. Like I cannot reverse this process. I have to apply another process where I remove heat from the system. But if I'm doing it by changing the volume, if I'm doing work on the system, so I can reverse this at any point, like by changing. So what I'm doing here is I'm slowly increasing the pressure so that the temperature is increased. What I can do is I can change the pressure by changing the movement of the system. So that way it becomes a reversible process. I can reverse it just as easily because the change, with every little change in the pressure, my temperature is changing accordingly. Get it? Like, is this better? Is that clearer?
I still don't understand.
I didn't get it either.
I didn't get it.
The whole thing, or is there any part of it?
I understood the part when you said like you used like the pressure you move, you put it down, that the volume will decrease, that part, and how like you use the other substance to like work with it. Like that part I had, but then uske baad it was all haywire for me.
Okay, like
I
how
don't
it relates to reversible, irreversible is where you got lost. Okay, Kaveri, what about you?
I didn't understand anything.
Okay. So first step is by adding heat to the system. So this is my main aim, to increase the temperature of whatever is inside this system. Clear?
Yeah.
Okay. तो temperature increase करने के लिए I can use two methods. One, I can directly add heat energy by supplying a flame to it. Or two, I can add that energy by doing work on it. Two ways of adding. See, temperature change karna matlab I'm basically manipulating the internal energy of the system. So let's talk a little bit about internal energy. Baad mein aayega, but it kind of makes sense to talk about it here. So internal energy, it is depicted by U. Okay, so this is a theoretical value because there is no practical way to measure. Abhi, if I say mobile mein total kitna energy hai, like iska internal energy kitna hai, like it is impossible to measure. So what is internal energy is basically, it is the intrinsic energy that is contained in the system. So when I say intrinsic energy, abhi a substance is made out of particles, right? Like atoms, molecules, whatever it may be. So particles hai, particles ke beech mein you have like bonds, be it hydrogen bonds, chemical bonds. They would have like some amount of attraction, repulsion, all of that is there. Now each of that is, and then the particles themselves have motion also, right? Like they may be vibrating in their places, or agar gas hai to they're just like moving all over the place. They may be rotating in its place. However they are, you have forces of attraction, repulsion jo bhi hai, you have motion of the particles. So the all of the energy associated with it, so all the potential energy associated with the forces, all the kinetic energy associated with it, like forces matlab bonds and forces. So all of this energy together is called internal energy. Okay, so that's something inherent. If something exists, it will have its own internal energy. And depending on how much internal energy it has, that decides ki, okay, us substance ka temperature kya hoga. So you can't measure the energy directly. You can measure the temperature because that's something we made up to figure out ki, acha, this is hot, this is cold. So the energy inside it, inside the hot thing is more than the cold thing. So how do we make sense of it? Okay, we'll use temperature to call it that, degree of hotness.
Energy is dependent on temperature.
It's not, they're not different, they are the same things. Internal energy, what we can see it as in the real world is temperature. तो अगर टेम्परेचर इंक्रीज हुआ, इसका मतलब उसके अंदर जो पार्टिकल्स है वो they are vibrating, moving, whatever, their motion has increased, which means their kinetic energy has increased. So basically their internal energy overall has increased. So increase in temperature matlab internal energy has increased, decrease in temperature matlab internal energy has decreased. We don't have a way of directly, like just say kinetic energy of a ball or something, we can calculate it as half mv square, but we can't calculate every single particle ka kinetic energy and the bond energy and all of that, right? So there is no way to calculate our internal energy in joules, but there is a way we can detect internal energy change hua ya nahi hua, that is by temperature. So agar temperature change hua matlab there is a change in the internal energy.
What did you do in the pistol then?
Coming to that, like clear about what is internal energy?
Yeah.
Okay, उसका direct relation है temperature के साथ. Now let's say in this setup अंदर जो gas है, I want to increase its temperature from 10 degrees to 30 degrees. So temperature increase हो रहा है मतलब I am increasing its internal energy, right? तो कोई भी energy increase करना है. Now energy can't be created out of nowhere, right? I have to put it in from somewhere. Like it can be transformed. I need to source my energy from somewhere. So my two sources of energy, either I can do it by heating it, by giving it heat energy directly. So the heat energy gets converted to internal energy of the particles. Or I can do work on the system, like without involving any heat. So whatever work I do in the system, so that gets converted to internal energy. So work is like, you guys have studied work, right? Like you had work power energy. So what do you know about work? What do you understand by work?
Work is equal to energy, like magnitude wise.
Magnitude, I mean, dimensionally, yeah, work is equal to energy. So work, so energy is the capacity to do work. Like energy can be converted into work. Similarly, work that is done can be converted into energy. Like when you do work, like if I'm doing work by pushing this stylus, I'm converting it into kinetic energy. Like it's getting converted into kinetic energy of the stylus. So work and energy are like, they're not the same, but they're transferable. Right? So that is what I'm doing here. Either I can give it heat energy and then that will be converted to internal energy, or I can do work on this and that gets converted into the energy on the system. Okay. So when I'm giving heat, that's directly affecting the internal energy of the system. Like it's not something I can control. I mean, if I give it like 300 kilojoules at once, it's going to, this whole thing is going to get heated up. Right? But like alternatively, if I'm doing work on it, so doing work on it matlab let's say I'm pushing the piston. So when I'm pushing this piston, like that's why I'm doing work on this in the form of like moving this here, Fs cos theta. Then the volume is decreasing. Kaveri, that makes sense?
Could you repeat this?
So when I'm pushing the piston down, the volume is decreasing. Yeah, iska?
Yeah.
If volume is decreasing, how does that affect the pressure?
Pressure increases.
Pressure increases. So if pressure inside is increasing, how does that affect the temperature? What is the
It
relationship
also
between pressure and
increases.
temperature?
Temperature also increases.
Increases. There you go. So without involving heat, this is my second way of increasing the temperature by doing work on this.
Got it.
Now let's see the second thing. So when I'm doing work on this, I'm basically pushing the piston, right? So I'm not increasing the pressure straight away from like, I don't know, 1 bar to 2 bar. So when I'm pushing it, I can push it like 1 bar, say 1.1, 1.2, 1.3, 1.4. So accordingly, the conditions inside will change. I can also change the condition, like because it's happening slowly in like a stepwise manner. Once I change the conditions, the process can be reversed. Right? Which is not the case when it's, just directly, like when I don't have any control over changing the conditions, like in the case of applying heat. Make sense? Okay.
Can you repeat what you just said?
So when I'm pushing this and when I'm changing the conditions slowly, like from 1 bar, if I'm increasing it to 1.1, then going to 1.2, then going to 1.3, like step by step, I can easily reverse the condition also. Like if I decrease the pressure back to like 1.25, then the overall effect that it has on the system also is reversed.
Yeah.
So that's the difference between a reversible and irreversible process. But if it's not happening at this kind of a scale where I can change the condition and reverse it, if it's happening in one step that, oh, I put in 300 kilojoules of energy and all of it got converted into internal energy, now I have to apply a separate process to it. Like I can't take it back, right? Like I need to find ways of cooling it down. Completely different process. So that's an irreversible process. When I can't reverse the process by changing the conditions of it, that's a that's an irreversible process. But in the case of a reversible process, it can be reversed because the change takes place in like infinitesimal steps, like tiny steps. It goes like stepwise for fashion way forward. That tiny change in the condition, I can like go one step back. So at any instant, as long as it's going forward, like I have an option of like turning back. Irreversible process may, from here, okay, I just like did something to it, it got here. So I don't know how it got here. So there's nothing I can do to get it back here again. Like I can't reverse the process. I can't like reverse the process. I can get it back here by applying a different process to it. Yeah.
So
Ma'am,
the 1.1 to 1.2 to 1.3, that's for reversible, right?
Yeah, because I'm increasing it stepwise. So kabhi bhi I can like go backwards.
And in the same process, if we make a sudden jump, then it will be irreversible.
Yeah, because like I don't know, like I can't change any conditions to come back because I already got my change already.
Yeah.
Guys, can you like switch on your video, because I have no idea where you're at, whether you've gotten it, whether you're paying attention or anything like that. Yeah.
ma'am, is it possible? I know I've already asked, but I still didn't get what exactly the term state function means. Like, is it just that in particular temperature, volume, at, I mean, just in a particular time you just measure that? Is it that or what? I still didn't get it.
State function describes the state of a system. कौन सा pressure पे है, कौन सा temperature पे है, कौन सा volume है, all of that. Path function describes the path. The process में क्या हो रहा है? Are you adding heat? Are you taking away heat? Are you doing work on it? How are you doing it? Like that.
So, like, they are not really connected with each other. I mean,
No, no,
each
no.
other. So it's just that one says the path and one says the state.
Yeah.
Okay.
Ma'am, when we say path, what do we mean?
Process. क्या हो रहा है? Like state is point A, point B. यहाँ पे एक pressure, temperature, volume है. यहाँ पे दूसरा pressure, temperature, volume हो सकता है. Path is like how are you getting here? क्या process ले रहे हो in order to get from here to here? Are you supplying heat? Are you doing work? Is it a combination of both? Like what exactly is happening here? So this is a state. This is another state. Path is what, how are you getting there? Ritu was saying so change of phase is irreversible. Yes. I mean, again, it depends on what it's a process, right? So it depends on what process you do to bring about that change of phase.
Ma'am,
Huh.
But like, okay, you can go.
What?
in the divided by boundary thing, you wrote diathermic and adiabatic. So adiabatic though we wrote, but we didn't write anything about diathermic. So
These are
under
describing things. These are types of boundaries. If the boundary allows heat exchange, then it's diathermic. If the boundary does not allow heat exchange, it is adiabatic. Like if it's like a metal, it conducts heat, it allows heat to go through it. So a metal would be a diathermic boundary. Like flask as a boundary, कोई भी heat exchange नहीं हो रहा है, you can't feel anything. So that's a, these are types of boundaries, like real things, like things that separate. These are types of processes, like end of the process. If you're not dealing with heat, if you're not heating, if you're not cooling, and even if you do, like if you do something in a flask where heat does not affect it, there is no heat exchange involved in the process, that's called an adiabatic process. Adiabatic boundary describes a boundary. Adiabatic process describes what type of process it is. Okay. So we'll do a couple of examples, like we'll do an example question which describes like all these different processes and things. It might make things a little more clearer. Okay, so irreversible is, so in this case, change takes place infinitesimal. Infinitesimal basically means like tiny, 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 infinitely small kind of. Okay. This.
Ma'am,
All
of this theory, we'll just simply get theory-based questions.
Less than theory-based questions, this will help you solve questions, because you may be given directly that, oh, this is an adiabatic process and the temperature increased from here to here, then calculate the work done. So you should know adiabatic process में heat exchange नहीं रहेगा. So whatever change in internal energy is all work done only, like that. So
we will have numericals also.
This is completely numericals. Thermodynamics, physical chemistry chapters, all numericals. This is states of matter may you've seen gas laws and all, right? Similarly, this is also completely numericals. But numericals understand karne ke liye, you need to be familiar with these terms. So, yeah.
Ma'am, how many more classes will this chapter take?
I was hoping we can do it by today, tomorrow. Let's see. So like it takes so slow that direction can be reversed by change in the conditions. State basically. Thoda sa pressure change karne pe direction can be like reversed. Temperature change karne pe you can like reverse that process that way. Irreversible mein direction cannot be reversed.
This is under process only, right?
Yeah, these are the types of processes. Usually it has been observed that so the work done in an irreversible process is less than the work done in a reversible process. This has been observed like generally across the board. Okay.
What is that word? Change takes place?
So change takes place infinitesimally slow. Like, so mathematically, what d represents, like when we say dv, extremely tiny change in the velocity, right? Like that way. So once you're done, we'll do an example, like what sort of questions you might get and how do you identify the types of processes. Then yeah, after that, I also need to get some water. Okay, so work. So derivation for work, what to do? Heat is like just heat towards heat capacity and all we can ignore. Do you guys remember the laws of thermodynamics? Were you guys taught as zeroth law, first law, second law, or was it first, second, and third law?
We haven't done thermodynamics.
Oh.
Wait, what is this exactly? Like in this chapter, or like in general?
This chapter. And that's like
We've never done.
you never done this chapter, like thermodynamics start nahi kiya, but you did equilibrium.
Yeah.
Oh. Okay.
In Potar, we did both. Yet I still think you just whatever you said was a foreign language.
You never heard of like zeroth law, first law, you don't remember?
I've heard the term, so I don't know the definition of it. I know our teacher was talking about it, that's why. She's like, you learn this in thermodynamics.
Huh. So was it zeroth, first, second that they were talking about, or did they talk about first, second, third?
The zeroth, first, second.
Acha, theek hai. Content is the same, but naming convention like may be different. That's why I wanted to clarify. Theek hai. I think we'll finish till this. Enthalpy pura will take tomorrow. Because we need to do understanding enthalpy. Uske baad, like some 50% of the chapter is types of enthalpy only. Reaction enthalpy, enthalpy of formation, all of that stuff.
Ma'am, did we have to note down what you wrote for the piston and all that potential kinetic that you drew
Not
for
if you want it for your reference or something, I can share a video with you. I can give you examples and all, but that was majorly for understanding aspect. You didn't have to.
But will they ask about the
No,
what was it called?
Cases, scenarios, examples, they won't ask. They will give you a scenario and you have to do like numericals and all on it, but they won't ask you to describe it.
Okay.
Does this chapter have like derivations or like direct formulas, like how we have for mechanical properties of solids and all?
Formulas, derivations, बस work का derivation है, but the probability of you being asked for derivation is less because there's much better questions that can come from this chapter.
So it's more formula based. They give you like PV and RT is like a formula, then you
Yeah.
apply that and then
Yeah.
okay.
Okay. Sanat, Smera, Rishit, Arnav, you guys done?
Yeah.
Keep your video on, guys. That'll be more convenient. So these are the kind of questions that you'll get. Okay. So this is a PV graph, pressure on the y-axis, volume on the x-axis. These are like specific states. You have A, B, C, D, E, and F. The path, so you're going A to B, B to C, C to D, D to E, E to F, and back to A. So this is like a cyclic process overall, if you take a look at it. Now what you're given is A, B, and F. These three are at temperature T1, and C, D, and E are at temperature T2. Okay, so given this information, can you identify what is the type of process that's happening here? Like A to B क्या process है, B to C किस तरह का process है, C to D what is the type of process? You need to identify the type of process.
Have you written that as density or pressure?
Pressure, P for pressure.
So are you like talking about if it is reversible or not?
No, like uske pehle bhi we came across, we looked at different types of processes, no? So adiabatic.
Is A to B isobaric?
A to B, isobaric, Sanat says. What? It can be multiple also, huh? Like isobaric, yes, because you can see that pressure is constant in both cases. What else can it be?
Isothermal.
Isothermal.
Isothermal, because A and B are at the same temperature T1. Okay. So similarly, B to C, किस तरह का process है? So look at what's happening B, C. So B may pressure, like when going from B to C, the pressure is reducing as the volume is increasing. So volume is increasing, pressure is decreasing. Actually, let me give you information about temperature also. ये तीनों T1 है, ये तीनों T2 है ना. So T1 is greater than T2. So temperature is also decreasing as you go from B to C. So what can you say about this process going from B to C?
Reversible?
Reversible, sure.
And what was decreasing here again?
So pressure is decreasing, temperature is also decreasing, and volume is increasing. Volume V1 इधर है, C का volume इधर है.
Isochoric.
Isochoric कैसे? Volume is also changing.
On the volume remains.
Ma'am, I didn't
Guessing
understand
it's like
how
some
it-
sort
Is it
of
adiabatic? No.
Wait,
But
Kaveri,
isn't it reversible?
1 second. Kaveri, you didn't
Can you
understand.
explain how A to B is isobaric, isothermal? I don't know.
Isobaric process क्या होता है?
Where the change in pressure is zero.
मतलब pressure change नहीं हो रहा है, right?
Yeah.
So compare the variables in A and B. So you know pressure, volume, temperature. Pressure change हो रहा है क्या A to B?
No.
तो इसलिए isobaric. Temperature
No,
change.
isothermal.
Temperature change हो रहा है क्या from A to B?
How would we know that?
So I've given you the information here. A, B, and F are at temperature T1. C, D
Fine.
are at temperature T2. And I've also given that T1 is greater than T2. Isothermal. हाँ. So B to C, volume increase हो रहा है. So expansion is taking place. And as volume increases, but
Pressure
pressure
decreases.
decreasing. And at the same time, temperature is also decreasing. So this is adiabatic expansion. So like temperature is not increase. See, if pressure remained the same and like you increase the temperature इसलिए volume increase हुआ or something like that, then you can say अच्छा वो तो isobaric हो गया and you've given it heat, so it's not adiabatic. Like that's the reason for this thing. But in this case, PVT, all of them are like changing in accordance with each other. Matlab, you didn't have to involve any external heat or anything else also. So pressure decreased and you're increasing the volume. Accordingly, the temperature is also changing. So that's it. Now C to D.
Isochoric.
Isothermal.
Yeah, you can say isochoric and isothermal. CD both are at T2 and the volume is constant. There you go.
Ma'am,
Hmm?
so you're saying BC is adiabatic because there was no real addition of heat, right? Since it's reversible, that is why it decreased. So that is what you're saying
Since it's
is the reason.
reversible, it happened to be reversible, and there is no addition of heat or like removal of heat. That's why it's adiabatic. So the temperature change happened because in accordance with the change in pressure and volume, like P PV upon T equal to PV upon T, like वैसे हुआ. D to E. What can you say about that?
Isobaric and isothermal.
And isothermal.
Yeah, just mirroring A to B. Yes. Okay, what can you say about E to F?
Adiabatic.
Adiabatic again.
Expansion.
Spiral.
Like adiabatic is correct, but is there expansion or contraction taking place?
Compression.
Compression or contraction rather.
Yes. Okay. Volume kam ho raha hai, it's getting compressed. And F to A?
Same as C.
Isochoric and isothermal.
Isothermal.
Yes. Okay. So this is one type of question you'll be asked. You'll just be given graph of a particular process and you'll be asked to identify ki kya hai. This is kind of how you can get familiar also at identifying kya ho raha hai. You can see like AF volume is the same.
We
Pressure,
draw this whole.
temperature is the same. You can note it down. Yeah. 454 ho raha hai na? Like note it down. Yeah. We'll take a little break. 5 o'clock ko we'll resume. Finish off work and heat.
This whole graph is like symbolizing irreversible, reversible. What?
Cyclic process. So this is a cyclic process. Cyclic process because A se chalu hoke it's come back to A. So wherever you start, if you follow the arrow, you'll come back to that point. Cyclic. Okay, we'll meet back at 5 o'clock only. Guys, videos. Sanat,
Yes, ma'am.
video. Oh, video is not connected only. Like, do you use an external webcam or something?
Wait, it's not.
No, I can only see audio.
Wait,
Is
hold on. Can I rejoin?
Yeah, make it quick.
I'm sorry. Could you explain again why it's adiabatic? I don't understand. The expansion compression part I understood, but why is it adiabatic?
Because there's no heat exchange happening there. Like whatever, see, temperature has changed. Temperature changed, matlab internal energy has changed. So internal energy is basically like temperature change, matlab कुछ तो energy changes हुआ. तो कहाँ से आया वो energy change? Either it could have come from heat energy, or it could have come from work done, like either on the system or by the system, right? So if pressure and volume were constant, इसका मतलब है कोई like no work was done on the system, like there's no motion or anything that was done on the system by the system. तो फिर कहाँ से आया वो energy change? Okay, heat energy, like it happened because of heat energy. Some like either I added heat energy or took away heat energy. But we can see here clearly that there is a change in the pressure and volume. So now we'll discuss how pressure and volume are related to work. Like let's finish this rest of the class and hopefully it'll get clearer. Okay. Yeah. Work. So work ka introduction definition to you guys are familiar with. We've been talking about it all this time. So work is a mode of transfer of energy okay. So specifically when system and surroundings differ in pressure until the pressures are equalized. Okay. So take it one phrase, one step at a time. So work is a mode of transfer of energy. So it is a type of energy, or it is something that gets converted to energy. Now, what is driving that conversion into energy? Like where are we getting that energy from? So energy ka different types are there, no? Like you have heat energy, like mechanical energy, like sound energy, electrical energy, potential energy, all of that. So work is specifically, at least in thermodynamics, like the context that we are studying in right now, it is driven by the change, like the difference in pressure. So agar system or surroundings are at different pressures, then when the process is such that, when the process wants to make the pressures equal, that's what it's driven by. So when the pressures become equal, then when you observe the system, there is energy added or taken away from the system. So the thing that caused that change in energy is basically your work done. Like simple terms, again, so since we're talking about pressure and all, let's get back to a piston wala system. So let's say we have a cylinder, like imagine your injection wala cylinder. So you have a piston that is movable. So inside internal system ka ek pressure hai, and the surroundings are at another pressure, let's say P dash. So agar P dash is greater than P, so what will you expect? Like, will it all remain the same, or do you think it's going to affect this piston or the gas or like the system in general? If P dash is greater than P, outside pressure is greater than the pressure that is there inside, तो फिर क्या होगा इस piston को?
The outside pressure will try to go inside, like pushing the piston down.
हाँ, So pressure is nothing but force per unit area, right? Like if somewhere pressure is more, there's going to be force applied. So piston moves downward. Okay. Now, if you consider the reverse case, if P is the one greater than P dash, अंदर बहुत ज़्यादा pressure है, less than the outside pressure, then what will happen?
Then the piston will
Piston
go up.
starts going up.
Yeah. So यहाँ पे pressure ज़्यादा है, तो the gas inside is gonna end up pushing this ऊपर. So piston.
So, ma'am, it cannot hold it anymore, right? So that is why it goes up.
Yes. So there is a pressure difference here. The upward moving, like moving up or moving down, is happening because like the pressure wants to be equal. Like equilibrium tab hoga when upwards, if the pressure coming from up and the pressure coming from down, if both are equal, then it will be balanced. Then there is no motion, there is no expansion, there's no contraction, kuch nahi hoga. But if there is a difference in the pressure, wherever there is more pressure, that's going to end up exerting more motion. Like that's going to end up exerting force. And that particular force is going to cause a motion in the piston, which in turn changes the state inside this thing. Like there's going to be a difference in the volume, there's going to be a difference in the temperature. So all that is going to end up in difference in the energy. So basically the moving of upward, downward, like that motion is basically what we call as work, because that's causing the change in energy inside. Okay.
But acha, okay. So if it is just generally unequal, then
it won't stay still. Like wherever the pressure is more, it's gonna end up pushing.
and if you push, that is work.
Yeah. Like when I push, like you guys studied in physics also, right? Like if I have a mass and I'm pushing it, वहीं से आ रहा है Fs cos theta. F is like the force I'm applying. S is how much I'm displacing it by. So that F into S is the work that I'm doing on the mass, which is getting converted into the kinetic energy, because this is ending up moving at whatever velocity. Right? That way. Okay.
Ma'am, could you explain the energy part again?
So yeah, like when there is a difference, like when the volume, temperature, pressure ends up changing inside, like for this gas, that ends up like that means it's a change in energy, right? Like change in temperature is change in internal energy, right? So that's how work is the transfer of energy. So doing work on the system or work being done by the system. So if there is work done either on the system or by the system, that means there is a change in energy. So like work is a mode of transfer of energy.
Could you repeat the last part again?
So work is a mode of transfer of energy. So what you have learned earlier is work is, so energy is the capacity to do work, right? So uska reverse hai, like it's exactly the reverse of that. Ritu, I think you're stuck. Yeah, I'll see you properly.
Same, yeah.
Okay. This is recording, right? Okay. We'll move forward, like when she comes back. Explain. Okay. So in general, like if we look at it mathematically, like this you can keep in mind because this is true in all contexts. So work is equal to the product of an intensity factor and a capacity factor. So, I mean, depending on the context, if I'm looking at work in terms of electricity, kuch aur hoga, like charges, electric charges and all, like work done to bring a unit charge. So, tabhi intensity factor is the potential, capacity factor is the charge. Mechanically speaking, intensity factor is the force, like kitna intensity se push kar rahe ho, and capacity factor is kitna push kiya, the displacement. So this is for mechanical work. तो इलेक्ट्रिकल वर्क में कुछ और रहेगा, मैग्नेटिक कॉन्टेक्स्ट में कुछ और रहेगा, बट इन जनरल whenever you take an expression for work, it will always follow this pattern. It's a product of an intensity factor and a capacity factor. Okay, so mechanical
I understood how intensity is like related to force. How is capacity related to displacement?
capacity is like how much did you displace it, like how much were you able to push, 1 meter, 2 meter, 3 meters, that way. That's the capacity factor. Okay, so this is something we've discussed earlier. So work ke expressions are generally negative when work is done by the system. The reason is that when system is doing work, system is like spending energy to do work. So isliye it loses energy. So if system has done 30 joules worth of work, it needed to spend 30 joules of energy to do that work in terms of like pushing the piston or whatever it may be. And when work is done on the system, takes on a positive value because something else is doing the work on the system, you're adding energy into work. Yeah. So this is like numerically magnitude, like if you're looking at the values, if you find that you ended up like calculation pura karne ke baad, you ended up at a negative value, it means that, oh, like work is done by the system. If you end up with a positive value, work is done on the system. So like when we talk about mode of transfer of energy, when work is done by the system, so energy is removed, like the system has spent energy in doing that work. Isliye the value is negative, it lost that energy. Work is done on the system, energy is added, like kisi aur ne kiya work on the system, they have added energy to the system. That's why it's a positive value.
Ma'am, I know energy added, like what that does, but when does a system work? Like when the energy is removed, what is an example of that when it is negative?
Let's say like system, ye piston wala case mein hi, if the piston is supposed to be moved upward, okay, like if the gas that is there inside has to push it, तो push करने के लिए it needs to like, so push करने के लिए it needs to spend energy, right? Then it can transfer that kinetic energy to the piston and then like move it upwards. So system is spending energy, matlab energy is removed from the system. You're taking energy out of the system. Like the system is losing energy. So that's why when work is
Understood.
done by the system, it's a negative value.
And like if we intentionally drop the piston, then like if we provide the energy and make it drop, then that would be addition because energy is added.
Yes. So external source से हम system में डाल रहे हैं, yeah. So that energy is added. Okay.
Ma'am, could you explain like it again, some like work?
So work is like it's a so it's a mode of transfer of energy. Okay, so basically you spend energy to do work, and when work is done on you, like you gain energy. So that's where that transfer of energy part comes into picture. So expression work is usually product of intensity factor and capacity factor. Like, for example, this is something you guys are familiar with. So mechanical work done is force multiplied by the displacement. So force is the intensity factor, like how hard did I push the mass. Capacity factor is, okay, how much did it move because of that force, like 1 meter, 2 meter, 3 meter, 5 meter. So intensity factor times capacity factor usually gives me the total work done. The same thing can be applied in other contexts also: electrical work, mechanical work, magnetic, wherever. Value of work, when does it take negative value, when does it take positive value? When work is done by the system is spending energy, like system is losing energy, so that's why it's negative overall. And when work is done on the system, something else is doing the work and adding energy into the system, that's why it's positive. Yeah. So we'll quickly look at the derivation of expression for work. So again, same piston cylinder case only. So let's say this is a cylinder, उसमें gas है, and this is the piston. Okay. Now, so these are the initial conditions. So the pressure that is applied is Px, and ये है Vx. Inside the pressure is P, let's say. So pressure and volume of the system are P and Vx. So make this Px. P external here. If the external pressure Pex is greater than P is applied. Okay, so basically we are doing work on the system. We are the ones applying the pressure. So something outside of the system is exerting pressure on it.
What is Vx?
Vx is the initial volume, like यहाँ पे जो volume है, that's Vx.
Okay.
So same piston है. So pressure apply किया. So this moves over here, let's say. Okay, so basically it has moved from this point to this point. So this will constantly move until till when?
Till Pex
Till
is equal to P.
Px is equal to P.
Correct. So the piston moves inside until the external pressure becomes equal to the internal pressure. So
But ma'am, I just have a small doubt. So, but this happening is very rare, right? Since if example external pressure is equal to P, but there will come a point where you cannot just move it anymore, even if you apply pressure or I mean apply force or anything.
Yeah.
isn't it?
Yeah, at that point, the internal pressure, like outside, यहाँ पे PEX जो है, that's equal to whatever pressure is coming from inside. If you're able to move it, means there is a difference in pressure. If you're not able to move it anymore, because the opposing force is also just as much, that both are being balanced. That's why it'll end up not moving. So what do you observe? Okay, pressure has changed from P to PEX क्योंकि ये equalize होना था. What do you observe about the volume? यहाँ पे Vx जो था, फिर यहाँ पे क्या हो गया?
Volume is reduced.
Volume decrease. Yes.
Please.
Okay. Okay. So let's do some physical calculations on this. What is the total force applied? Like हमने external pressure apply किया ना, तो what would be the force that is applied in moving the piston from here to here?
External pressure into area of the piston.
Right, correct. So PX into area. So pressure is force per unit area. तो उसी का direct apply करके we got force equal to PX into A. What is the volume that is changed? Volume decreases, na? Let's say the volume changed is delta V. What will that be equal to? So let's say the amount that is moved यहाँ से यहाँ तक is L. So what is delta V?
Vx minus L.
Minus? Guys, surface area volume.
Volume is equal to area into L, right? Area of the piston into L, or like area of the.
So volume is always area of the base into height. Like whether you take a cuboid, cylinder, whatever shape you're taken, it follows this format, like area of the base यहाँ पे जो है times the height. So change in volume मतलब area of cross section क्योंकि uniform cylinder है उतना ही रहेगा, but it moved L distance, right? So it's area times this length. Okay. So these are all the things. Okay, this is the situation.
Area is the cross-sectional area, right? Like of the piston.
Yeah. ये disc जो है, that area of cross section. That's why I've written it here. Okay. So let's take, abhi we know of reversible process and irreversible process. Let's take a simpler case. In the case of irreversible process, like if this change, like यहाँ से यहाँ तक जाना, if it is achieved in a single step. Use blue format. Okay. So if it happens in a single step, let's see how we can calculate the work done. So work done is equal to force into displacement, FdX. So what is the force that we figured in this scenario?
External pressure into cross-sectional area.
Px into A times displacement, meaning L. So what is the expression for L that I can use here?
Delta V
Delta
upon
L.
No, this itself is L, like delta of the distance is L. So what can I write it as? I can write L as delta V upon A.
Delta V upon A.
So L will be equal to delta V upon A. So A and A will be cancelled. So work done will be equal to the external force into delta V. So basically work done is P external into the pressure times final volume minus initial volume.
Ma'am, I have a small doubt.
Hmm.
I could be wrong, but if, for example, if the pistol does become equal to the external and the internal pressure, wouldn't push the particles would try to be as free as possible so that they don't apply a lot of pressure? Wouldn't that actually be an imbalance only?
What?
So like if there is a piston and you like push it till its limit, like it won't move anymore,
Yeah.
but wouldn't the particles try to be as free as possible and try to push it up only?
Yeah, so they're pushing it with the same force that I am pushing it. इसलिए वो balance हो गया ना. अगर कोई imbalance होता तो that's gonna move either this direction or this direction depending on whichever is greater. Particles are not conscious. They're not looking at अच्छा बाहर क्या है, okay, let's figure out our game plan. It's not like that. Particles are moving, they're applying a certain force here, that's the pressure. Now externally over here, I might have introduced a new gas, or I might be pushing this with my own hand. Whatever the source may be, the pressure on left side is greater than the pressure on right side. Isliye the left side is exerting more pressure, it's moving this side. And that's gonna happen. See, when I move this in this direction, while keeping the temperature constant, there is reduction in volume. Boyle's law, reduction in volume matlab pressure increases, volume decreases matlab pressure increases. So it's going to increase until both the pressures become equal, at which time like it's going to stop moving. So we are calculating work till the time the pressures are equalized, because uske baad there is no more motion, like there's nothing happening after that.
Okay.
Okay. So this is the formula for work. So it's pressure into the difference in volume if it is a reversible process, like if it's happening in a single step. Pretty straightforward, like single step. So you just know what is the final volume, you know what is the initial volume, and using the pressure and difference in volume, you figure out what is the work done. So the next derivation is if it was a reversible process, like if it is happening slowly, tabhi kya hoga? Should we continue this tomorrow, or do you want to just like finish off work done and then put an end to it?
How long is it?
Are you guys familiar with integration? Like, have you guys done integration in physics?
Yeah.
Yeah,
ma'am.
basics of it.
Basics of it, right? Okay. So there'll be some amount of integration involved in that derivation.
Then can we do it tomorrow?
5:35 right now. Okay, we'll do it tomorrow. I also have a meeting at 5:45.
Ma'am,
Okay,
could
ma'am.
you go to the previous slide?
Yeah, sorry. Yeah.
Yeah, done.